Section 6 in the math manual. This is section 6, basic concepts. We're going to go through, as it says, some basic concepts here. Things that you guys probably learned many years ago. They will be tested in slightly different ways on the SAT, of course, so we need to go over these to make sure you're solid on all the ways these concepts will be tested on this test. So first of all, in terms of fractions show up all over the place on the SAT because they factor into so many other types of problems. Actually, you can see on this page, we've got division and decimals and ratios and percents, all of which involve fractions. So all we're going to do here is convert all of these things to fractional form. Let me zoom in here a little bit. So, when we see a division symbol, obviously that does mean that we have a fraction bar. The division symbol converts to a fraction bar, so this would be 24 over 32. If we reduce that, which remember you can do in most calculators, especially graphing calculators, 24 divided by 32 in the TI-84, you can hit the math key and then hit enter twice, and it will convert that to a reduced fraction. So that would be 3/4. 0.75, remember that this 5 is in the hundredths digit, so this is really saying 75 1/100ths, which also reduces to 3/4. Ratios convert to fractions as well. That little colon between the two numbers will become a fraction bar, and we have 1 over 8. That does not reduce at all. 40%, remember the word per actually means division, and cent, the Latin root for 100, so 40% would be written as a fraction like this, 40 over 100, which reduces to 2/5. Then we have rates. Anytime we see a rate, again, there's that word per, 15 miles per hour can be written as 15 miles over or divided by 1 hour. That also does not reduce, but 20 miles in 4 hours, 20 miles per 4 hours, that in is sort of like a per and would again translate to a fraction bar. This would reduce to 5 miles per 1 hour. Oops. And then down here, this phrase for every, that would also convert to a fraction bar. 10 girls for every 8 boys, which would reduce to 5 girls, 4 boys. So again, many times when you see phrases or statements on the SAT that don't appear to be fraction related, they actually are fraction related, and very frequently converting to a fraction or writing a fraction will be your best bet. When you are performing fractional calculations in your calculator, if you are dealing with purely arithmetic fractions, I would just do those calculations right in your calculator. You just need to make sure that you are putting parentheses around all fractions that you handle in your calculator. Keep in mind that, again, some calculators have nice functions for handling fractions. They allow you to enter fractions actually in nice fractional form. If you want to know about any of those functions, you can ask your tutor. So in this case, we're going to do 2 divided by 7 in the calculator. I'm going to put that in parentheses. We're going to divide it by, again, parentheses, 3 divided by 5, and I'm going to math enter that in my calculator. And that's going to come out to 10 over 21. So again, all arithmetic fractions, purely arithmetic, non-algebraic fractions, in other words, with just numbers and no letters or variables, you can just do those in the calculator. Now, in terms of handling fractions without a calculator, you just have to know your fraction rules in order to add or subtract fractions. The rule is that the fractions have to have the same denominator. If they do have the same denominator, you can just add or subtract the numerators. If they don't have the same denominator, you need to find a common denominator. So in example 2, these have the same denominator, so we can just add or subtract. In this case, obviously subtract the numerators, and we get 6 over x. Over here, same denominator, so we can go ahead and add these two, and the expression we get is a plus b over 8. If the fractions, again, have different denominators, we need to go ahead and find a common denominator. Probably the easiest way to do this is the bow tie method, where basically we multiply this 3 by this x, and we get up here a 3x. We multiply this 7 by this 2, and we get over here a 14, and then we just multiply these two guys straight across, this 3 times this 7. So what we end up with is 14 plus 3x over 21. Now, of course, if you want to do this the regular old standard way, 2/3, if we want to convert that denominator to a 21 and this denominator to a 21, we have to multiply this 3 by 7 to get 21, which means we need to multiply this 2 by 7, and we get 14. And then over here, if we want to get 21 from that 7, we've got to multiply by 3. That becomes a 21. And then we need to multiply this x in the numerator by 3, and we get 3x. So in effect, obviously we did exactly the same thing we did with the bow tie method. The bow tie method just tends to be a little bit more brief, tends to be a little bit quicker, more efficient. So over here, again, let's do the bow tie method. We're going to multiply that by that, we get an x. We're going to multiply that by that, we get a y. We're going to multiply that by that, we get an xy. And what we end up with is y plus x over xy. That is adding, subtracting fractions. Multiplying fractions is very simple because we just multiply straight across numerator, straight across denominator. So this just becomes 2x over 9y. And same thing over here. One nice thing to do is to put all of your variables or whole numbers over 1 so that they appear as fractions. And then again, you just follow the same rule. Numerator by numerator, denominator by denominator, and you get 3n over 7. Dividing fractions. Remember that dividing by a fraction is the same as multiplying by the reciprocal of that fraction. So s over 3, this would become times 9 over t. I am just taking the reciprocal of this fraction, meaning I flip the numerator and denominator, or they exchange places, and then I just follow my multiplication rule. Straight across numerator, straight across denominator, 9s over 3t, which reduces to 3s over t. Over here, notice this fraction bar, this is example 4, this fraction bar is larger than this fraction bar, and therefore what's happening here is we're dividing 3 by 2/9. So we do 3 divided by 2/9 is the same as 3 times 9 over 2 times the reciprocal of this fraction. 3 times 9 over 2, I'm going to go ahead and follow my advice there. I'm going to put that 3 over 1, and I can see numerator by numerator, 27, denominator by denominator, 2. That is my answer. And then over here, notice the relative size of the fraction bars. We've got a bigger fraction bar on the bottom this time. So what we're doing here is we're doing 8 over c divided by 4. 8 over c divided by 4 is the same as 8 over c times the reciprocal of 4 over 1. Remember that 4 is 4 over 1. The reciprocal of 4 over 1 is 1 over 4. Straight across numerator, straight across denominator, I get 8 over 4c, and that reduces to 2 over c. So there are my answers for those examples. Fractions on opposite sides of an equal sign. Anytime you see fractions on opposite sides of an equal sign, anytime you see fractions on opposite sides of an equal sign, probably what you want to do is you want to cross multiply. Cross multiplication is an extremely simple way to handle situations like this. We go the left-hand denominator times the right-hand numerator, we get 8. We get the right-hand denominator times the left-hand numerator, we get wz. So these two fractions on opposite sides of an equal sign, they simplify to this slightly cleaner formula, the wz equals 8. And from that point, you might start throwing in numbers. You've got 2 and 4, or 1 and 8, or whatever you want, but this equation puts things in slightly simpler form. Same thing over here. We're going to do denominator on the left times numerator on the right. Remember that we need to make sure that we distribute properly here, so I'm actually going to write this out in a couple of different steps. Denominator on the right times numerator on the left is going to be 4 times 2w plus 4. I'm actually going to draw my little distribution lines so that I make sure I don't make any careless mistakes here. So this is going to be 12 minus 9w equals, and I'm going to do the same thing over here, that 4 times that 2w, that 4 times that positive 4. So this is going to be 8w plus 16. And then I'm just going to clean this up a little bit. In fact, I can just go all the way and solve. For w, I get 12 equals 17w plus 16. Subtract the 16. Subtract the 16. I get 17w equals 4. Negative 4. I'm going to divide by 17. I'm running into my next question here. Sorry about that. And I'm going to get that w equals 4 over 17. W equals, negative 4 over 17. So that's my final answer there. Those are your fraction rules. Again, you should have a fairly good sense of them, fairly good knowledge of them. If you don't, might want to hop online and do some fractional practice. I'm going to say once again that anytime you're adding, subtracting, multiplying, dividing just regular old fractions, your calculator will be your best friend. There's really no need to worry about fraction rules if your calculator can worry about them for you. Keep in mind there are ways to make careless mistakes using your calculator as well, so you've got to use your calculator wisely and carefully, but most fractional calculations are going to be easier with your calculator. Now, down at the bottom of this page 72, minimizing, maximizing fractions. What you have to keep in mind when you're being asked for the greatest possible value, so let's say they say something like greatest value of x over y, or they say smallest value. Sorry if that got cut off a little bit. Smallest value of x over y. In order to maximize or minimize the value of a fraction, what you need to do is think about what changes to x and y, your numerator and denominator, would make the value of this fraction bigger or smaller. And sometimes this can be a little bit counterintuitive, so it might be good to just not memorize this, but think about it for a moment, and once you think about it, you should understand it. If we want to maximize the value of x over y, what we need to do is we need to make x really big and or y really small. So if I start with 1 over 2, but then I make 1 a lot bigger, let's say I make it 4, and I make 2 into 0.5, then this becomes 8. So I've just turned 1/2 into a much bigger number by making the numerator bigger and making the denominator smaller. Now obviously this is assuming that ETS is allowing you to change the value of the numerator and denominator, but when they ask you for the greatest or smallest value of a fraction, that's usually what's going on, is they are allowing you to throw in numbers for the numerator and denominator, and you need to figure out what numbers you have to throw in to maximize or minimize the fraction. If you want the smallest value of x over y, you have to do the opposite. You have to make x very small and or y really big. So again, taking this number 1/2, if I make the 1 into, let's say, 0.5, I make it smaller, and I make the 2 something really big, like 1,000, then this guy becomes 1 over 2,000, some very, very small number. So I went from 1/2 to 1 over 2,000. I drove down the value of that fraction pretty darn far. So again, if you're maximizing and minimizing fractions, that's what you need to think about doing, manipulating your numerator and denominator in order to get the greatest or smallest value of the fraction. On number 16, you might want to go ahead and take a shot at this one on your own. So pause the video and take a shot at it. I'm going to go ahead and continue right now. Again, if you want to pause and do it on your own, do so now. So on number 16, they are asking us for the minimum value of this fraction. So again, we just said whenever they're asking us for minimum or maximum values of fractions, we have to think about what we need to do. If we want the minimum value of this fraction, we need to make this denominator as big as possible. Remember, we said that if we want the smallest value of a fraction, we need to make the denominator really, really big, or as big as we possibly can. If you can see right away how to maximize this absolute value of x minus y, then great, good for you. Go ahead and do that. What I'm going to do is, because most students will not see right away what values to choose for x and y, I'm going to go ahead and make a little t-chart, and what I'm going to do is I'm just going to throw in all the different combinations of the minimum and maximum values of x and y, so that I sort of find the boundaries of the value of this expression, x minus y absolute value. So I'm going to take first this 0 and this -5, so 0 and -5. So that's going to be absolute value of 0 minus -5, which is 0 plus 5, which is 5. So there I've gotten a denominator of 5, but remember, I don't know if 12 over 5 is going to be the minimum value. So I need to keep going and figure out if I can get any smaller value. By the way, 12 over 5 is 2.4. Since I'm going to be comparing the sizes of these results, I'm going to put these in decimal form. It's easier to compare the values of decimals than it is to compare the value of fractions. So I've gotten a 2.4. Then I'm going to do this 0 and this 0, but that actually doesn't work out all that well for me, because I'm going to have the absolute value of 0 plus 0, which is 0, and 12 over 0 is undefined, so I can't do that. Then I'm going to try this 5 and this -5, so the high end of x and the low end of y. So 5 and -5, that's going to be absolute value of 5 minus -5, which is 5 plus 5, which is 10. So now I've gotten 12 over 10, and indeed that is going to be smaller than 12 over 5. 12 over 10 as a decimal is 1.2. So it looks like, as of right now, that 1.2 is my minimum value. That's what they're asking me for, the minimum value. But I'm going to try one more combo here, and that's the 5 and the 0. However, the 5 and the 0 is actually going to give exactly the same result as my first set of numbers here. 5 minus 0, that's going to be 5. 12 over 5 is 2.4. So it looks like this here is my minimum trial. And indeed, the answer here is 1.2. You could also grid 6 over 5 would be acceptable as well. Either of those answers would be acceptable. So in order to minimize that fraction, I had to maximize the denominator, and I did that by throwing in x equals 5 and y equals -5, the biggest value of x and the smallest value of y. Next, we need to talk about averages. First of all, remember that when ETS says average on this test, they mean mean, and vice versa. When they say mean, they mean average. When we talk about the mean of a set of numbers, we're talking about the regular old thing that you remember from school, where if you score an 81 and a 94, and then you bomb the last test and you get a 63, of course, first of all, your parents get really mad at you and you get grounded. And then to find your average, what you do is you just add up the three numbers and you divide by 3, and then that will give you your mean, or otherwise known as your average. However, on the SAT, they will not tend to ask questions like this on the SAT. On the SAT, instead, some different things will be given, and different things need to be calculated. Your regular old average formula, as we just saw, I'm going to write it like this. Average equals total over number of things. A equals T over N. So this total is your sum. It's all the numbers added up. This number is the number of things that you added. So in the previous example, we added 3 test scores, so that N would be 3. And then your A is obviously your average. On the SAT, very frequently, it is... let me go ahead and do this in a different color. So on the SAT, usually oh wow, that's a big line there. Usually these two things, the average and the number of things, will be given, and what you will need to find, the missing piece, the unknown piece, will be this total here. And as an example, if I had told you that your average was 84 and you had taken 3 tests, well, then what you would have is you would have this equation, 84, the average, equals the total being your total number of points earned over the number of things. What you would do to solve for the total is you would just multiply these two numbers. You would multiply 84 times 3, because to get rid of that 3 in the denominator there, you would multiply that side by 3 and you'd multiply this side by 3. And what you would end up with is 84 times 3, that's going to equal your total. Well, translated back into algebra, this is average times number equals total, which, as you can see on this page, is the what I call the SAT average formula, ANT. Average times number equals total. And again, the reason it is nicer on the SAT to think of average questions with this formula in mind is because, again, if ETS gives us an average and they give us a corresponding number of things, our most efficient solution, our quickest way of getting to what we need, is to simply multiply those two numbers to find the total, or the sum of the numbers. That's the missing piece. So on example 1A here, let's take a look at this. If you want to try this on your own, you can press pause. I'm going to go ahead and work through this right now. So this question tells us that we have 4 rocks, so that's a number of things right there, and that the average weight of those 4 rocks is 27. So that's an average. So average times number equals total. Our ANT formula here would look like 27 times 4, the average times the number of things, and that's going to give us 108. Now, what is that 108? That 108 is the total weight of all the rocks. If we put all the rocks on a scale, we are going to see that the scale is going to read 108. That's the total weight in pounds of all the rocks. Now, the next half of the question is telling us that a rock weighing 30 pounds is removed. So what I'm going to do is I'm going to take a 30-pound rock away from that 108-pound total, and I'm going to end up with 78 pounds. And then look what the question is asking, total weight, 3 remaining rocks. Well, if I had 4 rocks whose weight was 108 pounds, and I took out 1 rock whose weight was 30 pounds, and I'm left with 78 pounds, that 78 pounds must be the weight of the 3 remaining rocks. That's one example of how ANT works. Numbers 3 and 11, you might want to go ahead and try them on your own. If you do want to try them on your own, press pause and pick up the video when you're done. I'm going to go ahead and do these right now. So on number 3, the average or arithmetic mean of 8, 21, and x is 21. They want the value of x. So could I set this up in the regular old average way? Yes, absolutely I could. But to get a little bit of practice with the ANT method, that's the way I'm going to do this. My average here, they say the average is 21. So I'm going to put a 21 there in my average column. The number of things, 1, 2, 3 things. So that's a 3. So my total here is going to be 63. That is the sum of all 3 numbers, the 8, the 21, and the x. Now, since I already have an 8 and a 21 here, I'm going to take that 8 and I'm going to take that 21 and I'm going to take them out of that 63 total, because if I take out the 2 numbers that I already know, I will be left with the 3rd number that I don't know, which is exactly what ETS is asking. So in my calculator, I'm going to do 63 minus 8 minus 21, and I'm going to end up with 34. That x, that 3rd number, must be 34. That is what they're asking, and I am done. So again, I found the total. I took out the 2 numbers that I already knew. That gave me the 3rd number making up that total, and I am finished. Number 11. In a class of 6 students, the average score of the 5 students who took the final exam on Tuesday is 82 points. The 6th student takes the final exam on Wednesday and increases average score for entire class to 86 points. They want to know points for the 6th student. So that's what they're asking. So again, if I scan through this question, I can see I have got an average right here. I've got another average right here. I've got a number of things right here. I've got another number of things right here. So putting this all together, again, because of all those ingredients, I'm going to go ahead and write down A times N equals T. My first average that I'm given is 82. I'm going to put that there. How many students made up that average? Well, there were 5 students that made up that average. So I'm dealing just with this 5 students having an average of 82 points. I'm dealing with that phrase right now. So 82 times 5, I'm going to multiply those in my calculator, and I'm going to get 410. So this 410 is the total, or the sum of the 5 students' points. So that is the number of points that 5 students amassed among them in order to get this 82 average. Then I am going to go to this next phrase, and it says the 6th student takes the final exam and increases the average score for the entire class, which, remember, is made up of 6 students. The entire class has an average of 86. So again, I'm going to put an average in my average column. I'm going to multiply that by the number of students that made up that average, which is now 6 students. And I'm going to multiply 86 by 6, that average, times that number of things to get a new total, and that new total would be 516. So this is the number of points that all 6 students amassed. Now, if 5 students amassed 410, and when the 6th student took the test, the number of points went to 516, then all I need to do to find out what the 6th student scored is subtract 410 from 516. And what I get is 106. So that 6th student must have scored 106 to bring the total points from 410 to 516. They are asking me what the 6th student scored. That is what I found, and I am done. So the answer there is 106. That was the 6th student's score. Next page is number 74. Again, on numbers 13 and 14 at the top of the page. You might want to try these on your own right now. I'm going to go ahead and do them. So again, pause the video if you don't want to hear the solution yet and you want to try it on your own. So average of 5 numbers is 18. The average of 2 of these numbers is 15. What is the average of the other 3 numbers? So again, it's pretty obvious. I'm going to go ahead and circle this. Average of the other 3 numbers. That's what they are asking. It's pretty obvious that this is another question on which we can set up ANT. Average times number equals total. Why is that obvious? Because they're giving us an average here. They're giving us a number of things here. They're giving us another average here, another number of things here. We've got the ingredients for an ANT question here. So the first average they give me is 18. The first number of things is 5. I'm going to multiply those two together. 18 times 5 is, I'm doing that in my calculator so don't make any careless mistakes, that is 90. So that is the sum of these 5 numbers. That's the total of these 5 numbers. When I add up all those 5 numbers, I get 90. It then says that the average of 2 of these numbers is 15. So I've got another average, 15. I've got a number of numbers that corresponds to that average of 15. That's 2. 15 times 2 is 30. So this 30 is the sum. So here, let's write down. This 90 is the sum of all 5. And this 30 is the sum of 2 of those numbers. Well, if 90 is the sum of all 5, and 30 is the sum of 2 of them, and I'm trying to figure out something about the other 3 numbers, well, the first thing I would probably want to do is I would want to say if I take this 30 away from this 90, I'm going to get 60, and that will be the sum of the other 3. Sum of other 3. And of course, 60 is right here in the answer, so we should go ahead and circle it. Correct? No, incorrect. That is not correct. Don't do that. I'm going to take that away. Because this question was not asking us for the sum of the other 3 numbers. It was asking us for the average of the other 3 numbers. That's why it's important to pay attention to what the question is asking. So I do have a final step here. And I'm actually just going to fit this final step right into my ANT formula. So what I'm doing here is I'm just putting A into the average column, because that average, that's the unknown now. So that will just be a variable. I have 3 numbers that make up this sum or this total of 60. So what I'm left with is basically this. 3A equals 60. I divide by 3, divide by 3. I get that A equals 20. That is my average of the other 3 numbers. That is what the question is asking. So my answer is D. Number 14. Number 14 is somewhat of a tricky question. It is very important to read this very carefully. Make sure that you know what they are asking. Make sure you know what they are giving you. So we've got this Alexis girl. She is calculating an average amount given by 20 donors as $150. So she says in this fundraiser they raised an average of $150, and that came from 20 donors. It was discovered that two amounts in the calculations were recorded incorrectly. Okay, so that's what they're telling us in these next two phrases. And then we need to find the correct average. So once again, I've got the ingredients for an ANT question. I've got an average. I've got a number of things. So that's what I'm going to start off by doing. Average times number equals total. 150 times 20 equals 3,000. That can just be done right in the calculator. So this 3,000 is the total amount given by these 20 donors. The only thing is that's not the right total, because in these phrases here we are told that some donations were recorded incorrectly. 120 was entered as 100, 170 was entered as 130. So if I know that somebody made a mistake and the correct amount was 120, but that was only entered as 100, what I need to do is I need to actually add the $20 to my total, because 120 was supposed to be entered but only 100 was entered. I need to put an additional 20 into my total to get up to that 120 donation. So that's going to take my total up to 3020. And then this 170 being entered as 130, I've got to do the same thing. I need to correct the 130 to make it 170. 170 was the correct amount. This 130 was what was entered. So I need to add another $40. Okay, 130 was incorrect. 170 was correct. I need to add the $40 to get up to that 170. So then I have my real total, my correct total, as 360, and I'm going to do something similar to what I did on the previous question. I'm just going to go ahead and fill in the other two pieces of this ANT formula. My A is what's missing. That would be the correct average that I need to find. The 20, the number of donors, that stays the same. So my formula here, or my equation here, is simply 20A equals 3060. I divide by 20, divide by 20. I get that, and again, this should be done in the calculator. My correct average should be 153. Again, that is what they are asking, and my answer is E. So that is ANT. It is very, very common on the SAT. On almost every test, you will see a question where you can use ANT. Is ANT going to be able to be used on every average question that you see? No, probably not every average question, but many of them. And on many of them, ANT is the best way to do the question. Now, a couple of other average notes, getting away from ANT slightly here. You got to be careful of automatically dividing by 2 on average questions. ETS sometimes sets up questions to make you think that you need to add a bunch of things and divide by 2, but that 2 might not actually be the number of things that you're dealing with. So number 5, might want to pause the video, try it on your own. In number 5, what we've got here, we've got one equation, we've got another equation. ETS is asking us for the average of these 4 numbers. But what a lot of students will do, since they know they need to add up these 4 numbers and they know that x plus y is 10 and y plus z is 30, some students will say 10 plus 30, and then they'll divide by 2 because they only see 2 numbers up here in the numerator. Unfortunately, that is not correct, because this number 10 is made up of 2 numbers. This number 30 is made up of 2 numbers, the x and the y and the w and the z respectively, and therefore we don't want to divide by 2 here. We actually want to divide by 4. So this would be 40 over 4, which equals 10. Is that the average of these numbers? Yes, it is, and we're done. Answer is A. The median. What is the median of a set? If you already know this, great. I'm going to go ahead and write down the definition. Median is the middle number in an ordered set. And that is very important. You have to remember that your set needs to be ordered before you go about trying to find your median. If you get a set like like this, 3, 1, 2, you cannot just say 1 is your median. You would have to relist these in order. 1, 2, 3, 2 would be your median. That is the middle number in the ordered set. Couple of hints about medians. If you have a slightly large set and you need to relist your numbers, what I would do is I would cross your numbers off of the original set as you relist. So you would list a 1, you would cross off this 1. You would list a 2, cross off this 2. List another 2, cross off this 2. List a 3, cross off the 3, and so on and so forth. That will ensure that you don't skip or repeat any numbers in the relisting process. Just make sure you don't make any careless, it will help make sure you don't make any careless mistakes. Finding the median in a set with many members. A lot of students already know to do this and use this technique, but I would suggest the end-to-end cross-off method. So 60 and the 75 go, this low 60 and this high 70, this low 61 and this high 70, and so on and so forth. And you just keep going like that until you get to the number or numbers in the middle of the set. So the end-to-end cross-off method, probably the simplest, most systematic way of whittling your set down to the median. Sets with an even number of members. How do you find the median in a set with an even number of members? So for instance, here, if we have this 1, this 2, this 3, this 5, and this 7, and we want to know what the median is, well, we run into a slight problem. When we start this end-to-end cross-off method, we end up with 2 numbers in the middle. If that happens, what you need to know is that the median will be the average. So let's write down median is the average or mean of the middle 2 numbers. So in this case, the average of 3 and 5, we would just do 3 plus 5 over 2. That's how we find the average of those 2 numbers. 8 over 2, which equals 4. So the median in that set would be 4. Now, bait on mean and median questions. With examples 3 and 4, you might want to pause the video and see if you can get these on your own, or if you get bait on these questions. In example 3, we're dealing with this table here. Title of the table, items purchased by customers. We've got a number of customers in the left-hand column. We've got number of items that those customers bought in the right-hand column. There are 20 customers. This 4-hour period is completely irrelevant. And then they give us an example. 4 customers bought 3 items each. So that's obviously, that's this row. This is 4 customers bought 3 items each. Okay. So the first question, example 3, says, according to the table above, what is the median number of items per customer? What a lot of students are going to do is they're going to see in this column we've got number of items. We've got a 1, a 2, a 3, a 4, and a 5. So students are going to think, all right, well, the median of those 5 numbers is that 3. They're going to pick 3 and they're going to move on, and unfortunately they're going to miss the question. 3 is the bait or trick answer on this question. You have to understand that this 1, this 2, this 3, this 4, this 5, they don't all occur just one time. As I've written them in my list here, they don't all occur just one time. This 1 actually occurs 6 times, this 2 occurs 7 times, this 3 4 times, and so on. So what I would actually do on this question, I'll show you a slightly shorter way of doing this in a moment, but what I would do is I would actually list out all of my numbers. So I've got 6 1s, 1, 2, 3, 4, 5, 6 1s. I've got 7 2s, 1, 2, 3, 4, 5, 6, 7. I've got 4 3s, 1, 2, 3, 4, 1 4, and then 2 5s. And then I'm just going to start that end-to-end cross-off method. I'm going to do a few at a time here. I generally don't recommend doing this because sometimes it gets confusing, but I'm going to do it to make this a little quicker. 1 2 3, 1 2 3, 1 2 3, 1 2 3, 1. I'm going to start slowing down here because I'm getting to the middle. 1 2, 1 2, and then I can pretty much see that the 2 is going to be in the middle. So my median here is actually that 2. Now, if you want this to go slightly more quickly, and if ETS were to give you a much larger number, you would want a shortcut for this. So, oh, look at that. I just made a careless mistake. It's a good thing I had this written down. That was supposed to be crossed off. So that it's actually these two numbers. I have an even number of numbers here. So I'm going to have 2 numbers in the middle. See, everybody makes mistakes. I've got 2 numbers in the middle. Fortunately, I would have gotten lucky. My average is still, the average of these middle 2 numbers is still 2. So that average of the middle 2 numbers is still my median. So my median is still 2. But again, I did forget to cross off one of those 3s, probably because I was doing too much at once. So the slightly shorter way of doing this is to look at how many items you have in total. We have 20 numbers in total, and that means that our median is going to fall between the 10th and 11th number. It's going to be, in other words, the average of the 10th and 11th number, because there's going to be 10 numbers over here, our first through our 10th number. Then we're going to have our 11th through our 20th number. So the median is going to fall right here between our 10th and 11th number. So how does that help us? Well, remember that if we're listing the numbers in order, there's going to be 6 1s. Okay, there will be 6 1s. And then there's going to be 7 2s. And that 6 1s and 7 2s is going to take us up to 13 numbers. But we were worried about what's going to happen between the 10th and 11th number. Well, remember, both the 10th and 11th number will fall within these 7 2s. Again, you can see that down here. You've got your 6 1s, and then you've got your 7 2s, and this accounts for 6 numbers. This will take us up to the 13th number. So somewhere between the 7th and the 13th number, our first 2 and our last 2, the median is going to fall somewhere in there between the 10th and 11th number, which means we know the median is 2. So again, if you get a question that asks you about a median and you've got a lot more numbers, let's say you've got 30 1s, you've got 40 2s, you've got 5 3s, you've got 15 4s, and so what is that up to? 70 and 20, 90. So let's say you have 10 5s. So you have 100 total numbers. So here there's 100 numbers. What you would do if you wanted to know what the median is, again, the median here is going to fall between the 50th and the 51st number. It's going to be the average of those 2 numbers. Well, you can see once again that both your 50th and 51st number are going to fall in these 2s, because you're going to have 30 1s, then you're going to have 40 2s, which is going to take you up to the 70th number, and somewhere between that 31st number, which is your first 2, and your 70th number, which is your last 2, you're going to hit both the 50th and 51st term, which means your median is going to be one of those 2s, or the average of those 2s in the middle. Hopefully that all makes sense. Again, if you don't have that many numbers, your best bet is probably just to list them all out and figure out your median that way. Now, the average of the number of items per customer. So average number of items per customer. Again, a lot of students are going to say 3, because 3 is right in the middle. But that is, once again, a bait answer. The average is not 3. The way that you would need to find the average number of items per customer is you would need to find the total number of items per, or divided by, the total number of customers. Well, the number of customers is easy because they give us that in the question. It's 20. How do we find the total number of items? Well, the way that we do that is we just multiply these numbers together. If 2 customers bought 5 items each, that's 10 items total. 1 customer bought 4 items, that's 4. 4 customers bought 3 items, that's 12 items. 7 customers bought 2 items, that's 14. And 6 customers bought 1 item each, that's 6. I'm going to add all of those up. I'm going to use my calculator so I don't make any careless mistakes. 10 plus 4 plus 12 plus 14 plus 6 equals 46. So that goes here in my numerator, 46 over 20. 46 divided by 20 comes out to 2.3. That is my average number of items per customer. So that is it for medians and bait on medians. The only other thing you might need to know is what the mode is, and we're just going to define this and move on. The mode is the most common number or element or item in a set. So for instance, in the previous question, the mode of these numbers would be 2 because that occurs 7 times. That is more than any other number in these this set of number of items purchased per customer. That is it for averages. We are moving on to ratios. What is a ratio? Ratio is just a relationship between two quantities or two numbers or two items. Relationship between quantities. Ratios can be expressed in 3 forms: colon form, word form, fraction form. This is the important form, the fractional form. That's the form that's going to be most beneficial to us in most questions, because that's the form that we can actually perform some mathematical calculations on. So the ratio of black to gray marbles in this bag, I have got 1 black, 2 black, 3 black, 4 black marbles. I have got 1 gray, 2 gray, 3, 4, 5, 6 gray. So remember, when we express ratios, we express them in most reduced form. So 4 to 6 would reduce 2 colon 3, 2 to 3, and then fraction form, which, like I said, is the form we want to be in, would be 2 over 3. So that is the ratio of black to gray marbles. What does the word respectively mean? We see this word a lot on ratio questions. It's important to know what it means so we don't get confused or intimidated. A basket of fruit contains only apples and oranges in the ratio of 5 to 6 respectively. What this respectively is telling us is that since apples comes first and the 5 comes first, they go together, they match up, and oranges come second and 6 comes second in each of these pairs, that the oranges and the 6 match up. That's what respectively means. It means in the order shown or in the order designated. So when you see that word, don't freak out. It doesn't mean anything big and scary. It just means that the first thing here matches up with the first thing here, and the second thing here with the second thing here. Ratios and fractional parts. Ratio questions, one of the things that ETS can do to spice them up a little bit is they can combine ratios and fractional parts. And the major difference is that in a ratio, we generally talk of ratios as being the fraction item over item. In other words, like item 1 over item 2. In the previous example, we had black marbles and gray marbles. But a fractional part is really going to be one of your items over a total, not one of your items over another item. So item 1 over a total, or item 2 over a total. So in the previous example with the black and gray marbles, remember we had 4 black and 6 gray marbles, and so our ratio of item to item was 2 to 3. But if we think about, the fractional part of the bag that was black marbles, it would actually be 4 out of our total, which is 4 out of 10, which reduces to 2 out of 5. Now notice that this 5 in the denominator, it's actually the sum of the ratio numbers, the 2 and the 3. If we add the black and gray marbles from our ratio, we actually get the total that we need in our fractional part fraction. So a lot of these questions will actually revolve around that idea of adding your ratio numbers to get your total in your fractional part. Examples 1 and 2, go ahead and do them on your own. Pause the video if you would like to do so. So this question says we've got cats and dogs in a kennel. The ratio of cats to dogs is 2 to 5 respectively, and they want dogs are what fraction of the total animals. So what we would do here is almost exactly the same as what we did over here. We would say there are 2 cats and 5 dogs. Thank God there are more dogs than cats, because if it was the other way around, That would be very sad. Everybody knows that dogs are superior to cats. It's just my opinion. Okay, if you like cats better, it's fine. There's no problem with that. So 2 cats over 5 dogs means that there are 7 animals in our ratio numbers. We see a total of 7 animals. So what we would do to get the fraction that are made up of dogs is we would just do 5 dogs over 7 animals. And that indeed, that 5/7, that is the fraction of animals that dogs make up. Example 2, we've got J, B, and D. They are sharing profits in the ratio 5 to 4 to 3. They want fraction that J receives. So we're going to do something similar here. J, B, D, 5, 4, 3. So obviously we're going to take that 5 and we're going to put that over the total number of items in our ratio numbers, which means we're going to add 5 plus 4 plus 3, and we get 5 out of 12. And that is the fraction of the profits that J will receive. In the example at the bottom of the page, number 15, this guy is a bit tricky. Again, might want to solve this, try to solve this on your own, see how you do. So pause the video, do it on your own. I'm going to keep working here. So pens in a certain cup are either blue or red. Ratio of the number of blue pens to the number of red pens is 1/2. Each of the following could be the number of the pens in the cup. So number of pens except. So could be number of pens except. So we're looking for the answer that cannot be the number of pens in the cup. Now, I'm going to go over the bait answer first, and some of you might have unfortunately gotten this bait answer. Answer choice C, answer choice, yes, answer choice C is the bait answer here. What most students assume is that since this denominator is 2, they assume that the total has to be even. They assume that the answer choices have to be a multiple of 2, and answer choice A, B, D, and E, these are all even numbers. They're all multiples of 2. So students will think that the one odd number in the answer is not a possibility for the number of pens. But remember that they are telling us that this 1/2 is a ratio of blue to red pens. So I have 1 blue over 2 red. So these answer choices in the, these numbers in the answer choices, these are not possible numbers of red pens. These are possible numbers for the total number of pens. So neither this 1 nor this 2 are immediately relatable to this total. The way that we have to relate the 1 and the 2 in our ratio numbers to the total is we need to do what we did in these previous examples. We need to say, all right, well, if there's 1 blue and 2 red, that means ratio numbers wise, that means there are 3 total pens. So, for instance, our fractional part that of pens that are blue would be 1 out of 3 total. Fractional part that are red would be 2 red out of 3 total again. So what we see is that our actual total needs to be a multiple of that 3. I'm going to show you this in one other way. If I have my red pens and my blue pens 1 to 2, my total would be 3. If I double all of these numbers, so I multiply by 2, I get 2, I get 4, total would be 6. If I multiply by 3, I get 3, 6, and then 9. So what I can see is that my total is always ending up as a multiple of that sum of the ratio numbers. I add 1 and 2, the ratio numbers, I get 3, and then my actual total is going to have to be a multiple of that 3. So the only answer choice that is not a multiple of 3 is this 8. The 6 is a multiple of 3, 9, 12, 24, all multiples of 3, all possibilities for the total number of pens. 8 is the one answer that could not be my number of pens. So that is it for ratios and fractional parts, although this next concept is slightly related to ratios and fractional parts. In terms of percents and probabilities, we have to remember that percents and probabilities actually are just fractions. and more specifically, they're fractions out of a total. Whenever we're dealing with a percent or a probability, our denominator in our fraction that we write, and we almost always are going to write a fraction when we're dealing with percents and probabilities, the denominator in the fraction that we write is going to be a total. So when a question says Jacob passed 65%, what you probably want to think is that means that he passed 65 out of every 100 total. So that's what I was saying. Our denominator in a percent question is a total, and that total happens to be, when we're dealing with percents, 100. That, again, is where the word percent comes from. Over 100, divided by 100, out of 100. That's what percent means. Probability is very similar. If a question says the probability of selecting a red sock is 4 over 9, that means that there are 4 red for every 9 total socks. It would be weird to have 9 total socks because one of them would not have a friend to pair up with, but this obviously could mean you have 8 out of 18 total socks, and then that would make more sense. But again, the point here is that in probabilities, this denominator is always a total. This 9 is a total, 4 out of 9 total. So in examples 3 through 6, that's what we're, through 7, that's what we're dealing with here, converting between ratios and probabilities or percents and vice versa. Go ahead and do 3 through 7 right now. I'm going to go ahead and race through these as quickly as possible. If you are very confident with these and you do them on your own, then just check your answers against what I write to make sure that you were correct. So on number 3, a drawer contains only blue and black pens in the ratio of 7 to 4. One pen is selected at random. Okay, so we're looking for the probability black pen. So again, I'm going to do this very quickly. We've got 7 blue. We've got 4 black. That's supposed to be a 4. They want probability that will be black, so we need black out of total. So that will be 4 black out of 11 total. So that is the probability that we will pick a black pen, 4 out of 11. Next, example 4, similar example. We've still got these same 7 blue, 4 black pens. Now they want percent of pens that are blue. So what we're going to do is we're going to do 7 blue out of 11 total, similar to what we just did in the previous question. And we're going to multiply that by 100, and that is going to give us our percent. 7 divided by 11 times 100 is going to be 63.6%. We could have also set up a proportion. 7 out of 11 equals what out of 100. It's the same exact solution, just written slightly differently. Number 5, we've got roses and tulips, and 2/3 of the flowers are roses, so this is 2 roses out of 3 total. Now they want the ratio of roses to tulips. So if there's 2 roses out of 3 total, that means there's going to be 1 tulip out of 3 total. Again, 2 roses out of 3 total. And if there's only roses and tulips, well, there's 1 more flower, and that 1 more flower must be a tulip. So 1 tulip out of 3 total. They want the ratio of roses to tulips, so it's just this 2, which is roses, to this 1, which is tulips. So our ratio is 2 to 1, or 2 over 1. However you want to write it, that is our ratio. Next, number 6, probability of selecting an odd integer from a set of integers is 4 out of 5. So, because this is a probability, this denominator is a total. That's 5 total numbers. This 4 is the odd integer, so it's 4 odd out of 5 total. And they want ratio even to odd. Well, remember, there are only odd and even numbers, or odd and even integers, I should say. So if there's 4 odd numbers out of 5 total, what does that mean about even numbers? It means there's 1 even out of those 5 total. And they want the ratio of even to odd. That would be that 1 to that 4, 1 to 4, 1 over 4. Again, however you want to write it, that is our ratio, 1 to 4. Example 7. 45% of the shirts in a drawer are white and the rest are red. What is the ratio of red shirts to white shirts? So we want ratio, red to white. So here we're given a percent. Remember that a percent is a fraction where the denominator is a total. That total is going to be 100. So this 45% of the shirts in the drawer that are white means 45 white out of 100 total shirts. If there are 45 white and the rest are red, that means that 55 of them are red. 55 out of that 100 total have to be red. That 55 is just 100 minus 45. That has to give us our red shirts. So they want ratio of red to white, so we're just going to do 55 to 45. I'm going to write this one as a fraction, 55 over 45, and that reduces to 11 over 9, I believe, but I'm going to check it in my calculator just to be absolutely sure. I'm going to enter that, and I've got 11 over 9. So that is my ratio of red to white shirts, which is what the question was asking. Moving along, proportions. This is page 78, proportions. So first of all, we should talk about some of the ways that we can recognize proportions, some of the tip-off clues for proportions. So here they are. Probably the simplest way is ETS could just come right out and say the word or words directly proportional, or the word proportion. So that's probably the simplest way. Another way is we could see any of these words. We could see per, at this rate. We could see for every. So any of those words would indicate that we're being tested on a proportion, but probably one of the most common ways that we should be able to recognize a proportion, and this shows up on the SAT quite a bit, is if we see a pair of items or units repeated in a question. And I'm going to go down here. I'm going to jump down to number 3 quickly so that we can see what that looks like. Notice that in number 3 we see this repetition, cups of flour, loaves of bread, and then we have loaves of bread, cups of flour. So we have that repetition of units. The cups of flour are repeated, the loaves of bread are repeated. Anytime we see that repetition, we know that ETS is testing us on a proportion. Now, what do we do when we know ETS is testing us on a proportion? I'm actually going to go ahead and write this down over here. So as soon as we recognize that ETS is testing us on a proportion, probably the first thing that we should do, I'll do this as A, B, and C. First thing we should do is we should write down 2 fraction bars and an equal sign. Second thing that we should do is we should start filling in the knowns. Okay, we've got 4 places in our proportion. We've got 1, 2, 3, 4 spots. We're going to start filling in our knowns, and then we're just going to put an unknown, a variable, in the spot that we don't know. And then only other thing we need to remember in that step that is extremely important is to write your units. And it talks about writing units up at the top of the page. We never want to write a proportion like this. We never want to write a proportion where we just have numbers. We're going to run the risk of making a careless mistake if we write a proportion like this, because we might end up putting numbers in the wrong place, multiplying numbers that shouldn't be multiplied. What we want to do is we want to write our units. We want to put dollars in the numerator, months in the denominator, and we actually want to write those units out. And then C, the third step, is we'll cross multiply. That's pretty much always the way we end up ultimately solving a proportion. So on number 3, most of you can probably do this on your own, and if you can and you want to, pause the video. I'm going to go ahead and do this right now. she has this recipe that calls for 12 cups of flour for every 5 loaves of bread. If Rachel plans to make only 2 loaves of bread, how many cups of flour must she use? So we're looking for cups of flour. We see the repetition of units, so I'm going to do the steps. I'm going to draw my 2 fraction bars and my equal sign between them. I'm going to start filling in my knowns. So I've got 12 cups. I'm not going to write flour since I only have flour here. 12 cups over 5 loaves. So notice I'm writing my units. And then I am only going to make 2 loaves, and I need to know how many cups. So I'm just going to write C cups. What do I do to solve? I cross multiply. This is the third step here. So 5C equals 24. Divide by 5. Divide by 5. I get C equals 24 over 5. 24 divided by 5 is 4.8. 4.8, which is this answer choice right here, answer choice D. Number 11, I would go ahead, actually try number 11 and 14 on your own right now. I'm going to go ahead and do these, but you should pause the video and try them on your own. So number 11, a factory produces only black and blue pens in the ratio 7:5 respectively. Factory produces total of 78,000 pens per month. They want to know how many blue pens does the factory produce in a month. So I can see that this is a proportions question. It doesn't have the exact same tip-off clue that we just discussed, but it has something similar. It's giving us black and blue, and then we see the repetition of blue over here. The other unit that they give us is the total. And remember that we can get the total from our ratio numbers by adding these 2 numbers. We just saw a bunch of questions where we did this quite a bit. And that's exactly what I'm going to do. I'm going to set up a proportion. I'm going to know that obviously I need blue pens in one spot. So I will do the ratio number of blue pens. So blue pens is 5. So I'll put that there. And then what I want, they actually want me to know or want me to find the number of blue pens, so I'll put that there. But how am I going to make the connection between these ratio numbers and this total? The way I'm going to make that connection is once again by adding the 7, the 5. And in my ratio numbers, that means I have 12 total pens. So these are my ratio numbers. And then over here will be my real numbers. And I have the real total. They gave me the real total. The real total is 78,000. So all I'm going to do now is I'm going to cross multiply 78,000 times the 5. I get 390,000, big number. And that's going to equal 12b. I divide both sides by 12, divide by 12, and what I end up with is that my number of blue pens is 32,500. Is that what they were asking? Yes, it is, blue pens, and I am done. Now, there are other ways to do this question. There are definitely other valid solutions to this, valid methods. This just happens to be the way that tends to be the most consistent and consistently simple method on the SAT. But if you had a different way of doing this that works for you and you're very confident with that method, then that's perfectly fine. On number 14, we've got a recipe for dough that requires flour, water, and salt mixed by weight in the ratio 6:5:1 respectively. In order to make 4 pounds of this dough, how many pounds of flour are required? So I do have the makings of a proportion here. I've got some repetition, flour, dough. So here's the way I'm going to do this. I'm going to do it almost exactly the same way as the previous question. Because I recognize it as a proportions question, I'm going to set up my proportion. I know that obviously pounds of flour need to be in my proportion. So I'm going to put flour there, and then obviously I'm going to put flour in the same place on the right-hand side of the equal sign. From my ratio numbers, I see that flour is 6. And obviously this is my unknown, so I'll put an F over there for my unknown. And then what has ETS given me here? They've given me that I'm making a total of 4 pounds of this flour. So On my left-hand side, I've got my ratio numbers. On my right-hand side, I've got my real numbers. So what I'm going to do is I'm going to put that total of 4 pounds in the denominator on the right. Now, what is the corresponding total from my ratio numbers? Well, remember, last few questions that we've done, last couple of pages that we've done, we've seen a couple of examples of this where we have to add our 3 ratio numbers to get our total. 6 plus 5 plus 1 is 12. So that's 12 parts total. The way that you can think about this is that if you think of each of these numbers being a number of pounds, for instance, when you mix this dough, you would have 6 pounds of flour, you would have 5 pounds of water, and you would have 1 pound of salt. And that means that you would actually have 12 total pounds of the entire mixture. 12 total pounds of the entire mixture because you have 6 pounds, 5 pounds, 1 pound of the flour, water, and salt. That would make 12 pounds of the dough. You just have to add the pounds of flour, pounds of water, pounds of salt. You get 12 pounds of dough. So if we were making 12 pounds of dough, we would have 6 pounds flour, 5 pounds water, 1 pound salt. But we're not making 12 pounds of dough here. We're making 4 pounds of dough. So that's what my ratio represents, that I would have 6 pounds of flour out of 12 pounds total. It's what we just went over up here. And now I want to know how many pounds of flour out of 4 pounds of dough. I cross multiply, I get 24 equals 12F, divide by 12, divide by 12, and I get that my pounds of flour in this mixture of 4 pounds of dough will be 2. And my answer is A, because they are indeed asking for pounds of flour. Again, there are other ways to think about this, to look at this, to calculate this, other valid ways. One way is to just look and see that you have 6 out of 12, which is 1/2. So 1/2 of the total pounds is going to be flour. So if you have 4 pounds, a half of that is 2. So again, there are other ways of doing these questions. I just think the proportional method tends to be most efficient and simplest to set up, especially after you practice it a couple of times. Couple more proportions questions to do here, and then we wrap this up. In number 11, you see the tip-off clue that I had talked about. This is pretty much the simplest of the tip-off clues. They tell us that we're talking about a direct proportion. A direct proportion is simply that proportion that we've written down a couple of times, where we have 4 spots, one over the other on each side of the equal sign. What I'm going to do here, since I don't have any units to speak of, is this. I'm going to write that I'm going to put my K's in my numerators and my J's in the denominators. And I'm actually going to write this over here, my K and then an arrow, my J and then an arrow, so that I know where my J's and K's are going. So they want the value of J when K is 1/9. So here's what I'm going to do. My first K is 1/3. And that corresponds to a J of 3/4. So I'm going to put my first K and my first J in the numerator and denominator on the left-hand side of this equal sign. And then in the right-hand side, my K, they've given me another K, that's 1/9, but I don't know my J. They're asking for my J. That's my unknown, so that's going to go in the denominator. When I cross multiply, I get 1/3 times J equals 3/4 times 1/9. I'm just going to do that in the calculator, and that's going to come out to 3/36. And from this point, there's a bunch of different ways that you could go. I'm actually just going to multiply both sides by, you could think about this as cross multiplication or dividing by 1/3, whatever you want, whatever's most comfortable for you. I'm just going to multiply both sides by 3 so that I get rid of that coefficient in front of the J. That 3 is 3/1. Again, I would just go in my calculator and I would get 9/36. I could grid 9/36. I could reduce it and get 1/4. I could grid in the decimal 0.25. I'm going to go ahead and grid 1/4 here, but any of those answers would be acceptable. So that is that. Main point here is that, again, even if you don't have units, traditional formal units, you still want to keep track of where you are putting what. Now, complex proportions. Sometimes ETS will not be asking you for a very simple, x1 to y1, x2 to y2 proportion. Sometimes there will be more than just an x or a y. They could say something like x squared is directly proportional to 2y, in which case your proportion would have to account for that specific proportionality. You would have to put an x squared over a 2y, another x squared over a 2y. Number 17 is a good example of this. I would pause the video and try to do number 17 on your own. So number 17 gives us a table of some values. It tells us that x plus 1 is directly proportional to 2y. So we can see this is not a simple x to y proportion. They are asking us for the value of a. So the way that we're going to do this is I'm going to first go ahead and write this down so that you can see how this is going to be laid out. So again, we can't think of this as just x over y equals x over y. We have to account for the fact that they are telling us that x plus 1 is directly proportional to 2y. So I'm just going to go ahead and pretend that these here are my my 1s and my 2s. In other words, this will be x1 and this will be y1. This will be x2. This will be y2. And in that way, I can just substitute. I can just plug in. So x1 is 2, so that 2 is going to go in here for x1. So I'm going to have 2 plus 1 over my y1 is also 2. So I'm going to plug that in the denominator. 2 times that y1, and that's going to equal my x2, which I can see from my table is 3. So this is 3 plus 1 over. Now my y2 is this a. So I'm going to just substitute that a into the denominator for my y2. And now I've got a pretty basic cross multiplication opportunity. This 2 plus 1 here is going to be 3 over 2 times 4, which is going to be 8. So 3 over 8 equals, this 3 plus 1 here is 4. And that is going to be over 2a. When I cross multiply, I get 6a equals 32. I divide by 6, I get a equals 32 over 6, which would be perfectly fine to grid in because that will fit. 3, 2 divided by 6. I am going to go ahead and reduce this. 16 over 3. I could also grid this as a decimal. 16 divided by 3 equals 5.33. That would also be a valid answer. I'm going to go ahead and grid the reduced fraction, 16 thirds. And there's my answer. So that is it for section 6. Just to recap what we went over, we talked about fractions. We talked about the fact that doing fractions, generally you can do fractions in your calculator if you're just dealing with arithmetic fractions, but you probably should be familiar with some of the fractional rules as well. I would say this multiplying fraction, this is probably the most important of these rules. It's rare that you're going to have to find common denominators, but it's very common that you'll have to multiply two fractions together. Fractions on opposite sides of an equal sign, you should cross multiply. You should know how to maximize and minimize the value of fractions. With averages, generally you're going to be using the ANT formula, average times number equals total. That is frequently the easiest way to tackle average questions. You should know that medians are the middle number in a ordered set, that modes are the most common number in a set. Modes are very uncommon on the SAT, but you should still know what the mode is just in case it shows up. Ratio, relationship between quantities, couple different ways to write ratios. Remember, you should know how to convert between ratios and fractional parts, and from fractional parts back to ratios. You should know how ratios relate to percents and probabilities. You should know how to recognize proportions. Gave you a few ways to recognize proportions. You should know how to set up proportions. You should make sure you write your units. And you might come across some complex proportions that don't give you the typical x to y type relationship, in which case you need to account for whatever relationship they define. That is all for section 6.